Welcome to The Connection, a series where we investigate and discuss the future of networking, cloud, and security technologies. We talk with thought leaders from academia and industry so that we can stay connected to what's going on and to what's coming down the pike related to technology and job opportunities. Cloud computing, network engineering, and cybersecurity have converged in several ways, driven by ever-changing technical capabilities, the evolving needs of the IT industry, and organizations' increased reliance on cloud services. I'm Dave Huff, Associate Dean and Director of the Cloud and Network Engineering and Security Programs at WGU, and I'm excited to get started. Before we meet today's expert panel, let's take a walk through the evolution of connectivity.
The need to communicate and collaborate is not new. In fact, societies throughout history have always created novel ways, using available technologies and techniques to share information or network. Networking is when multiple nodes are organized to send and receive data in a system. This could be carrier pigeons, post offices, the old pneumatic tubes that carried mail from office buildings. But all of them have some way to route messages to a recipient within a system. As digital computers came into existence, organizations began to quickly value access to their power, speed, and reliability. These early computers were called mainframes, and they were huge, originally filling entire rooms. And boy, were they expensive. There were not too many of them, and they had to be scheduled and shared by many organizations. The technology was therefore highly centralized, and there wasn't a really good way to access these mainframes remotely until the advent of the modem, which was the genesis of our modern electronic networks, and which could transport data at an incredible rate of 25 words per second. As computing platforms got smaller and more affordable, many organizations were able to buy and operate their own. Connectivity was still a challenge, but hardware called terminals, or dumb terminals, allowed users to access the central mainframes via internal proprietary networks. The data storage and computation were both done on the mainframe and remained centralized, but now users could start to share the data via the local network, not just the processing power of the machine. In the 80s, networking started to take off with the compatible intra-office networks and a new thing called the internet. And also, desktop computers arrived on the scene, and some even had their own storage. Imagine that. End-user computing, as it was called, presented great productivity gains, but local storage hindered the sharing and collaboration that centralized data storage offered. Enter the client-server model, the best of both worlds. Networks were reliable enough to transfer data back and forth, and desktop computers were good enough to process and compute locally. Remember modems? They were now blazing fast at 56,600 characters per second and worked over your home phone line. Soon, software was developed to run server-side, and the servers began to specialize into roles. Database servers, application servers, and load balancers handled specific roles more efficiently and allowed for hardware and software to be optimized into those roles. And then came virtualization, a technology that allowed multiple servers to run on shared hardware and set the stage for what we now know as cloud computing. The 2000s ushered in the advent of the cloud and a paradigm that really leveraged the concept of the World Wide Web and new higher speed networks between individuals and organizations. Because network speeds were acceptably high and reliable, and processing price was dropping, facilities that made up the cloud could once again handle both the data and compute elements, the digital transaction, and we saw a consolidation back to centralized computing, much like a full circle back to the early days of highly centralized mainframes, and without the capital expense of owning and maintaining on-premise equipment. Cloud computing leverages it all: low-cost servers, high availability and high-speed networks, centralized command and control, and state-of-the-art security capability. In the cloud, users don't have to be tech owners. They can simply license or lease the technologies that they need and focus on their key business lines. Sure, some organizations still want to host their own data and servers for control, for security, and other practical reasons, But even those organizations are mostly operating in some sort of hybrid fashion, where they maintain some of the infrastructure on-prem while leveraging the power of the cloud where it makes sense. This is where the technologies have really started to converge. But even centralized data traveling at speeds of light is not always fast enough, and the latest paradigm has seen a convergence of on-prem, cloud-based, and device-based data, and compute distribution that is being called edge computing, where data is stored where it needs to be and is synced to central servers where it can be shared and or processed as needed. This allows for the shortest possible latency by shortening the distance data has to travel. Hardware that supports network routing and security now works on-prem and in the cloud. Use cases have converged, as have the technologies that enable them. The convergence of centralized and network technology is complex and requires a great deal of orchestration to make sure that the data is secured, synced, and available when and where it needs to be in order to support today's complex business needs.
Welcome back. Today, I'm pleased to kick us off by introducing you to Benny Vargas and David Holsinger. Benny and David are lead academic program managers over the network engineering and cloud programs here at WGU. In addition to overseeing their respective programs, they're responsible for conceiving, designing, and implementing future academic programs, and they're the perfect team to talk to us about the topic of cloud, security, and network convergence. Let's set the stage. David, we saw some of it in the learning segment, but what would you say are really the benefits of cloud computing?
Yeah, sure. I mean, one of the biggest is that there are no capital expenditures for IT anymore for companies in a lot of cases, right? If you started a company 20 years ago, a big part of your startup investment went straight into hardware. And that's just not something that companies have to worry about anymore, right? You can just scale up and get going right out of the gate. Along with that, you don't have to manage licenses and things like server patches, and a lot of the just sort of nitty gritty of IT is handled for you because you're using somebody else's equipment, right? And talking again about that ease of getting going and integration. I mean, now with platform as a service, you can spin up, things like database servers and load balancers that used to be very fussy and, very painstaking things to set up. These are hassle-free now with cloud. I mean, it just sort of comes with the services, and at the same time doing that, now you also get scale and reach that wasn't even possible in the past, right? All of the companies you'd be working with, like Amazon or Microsoft, have global content delivery networks. So your application will work as well, in Asia as it does in North America, and there's no need to think about, optimizing networks and databases and things to be able to serve all those audiences at the same time.
So Benny, why do we even still have on-prem systems?
For starters, on-prem will always exist in some form. As for why some industries or institutions prefer it, I would point to performance and security. Performance in the form of low latency and high availability. Security for those that have regulations where data privacy and being able to safeguard customer information and compliance reasons are very key.
Benny, when it comes to enterprise networking, how do you see that evolving?
Since networks are so critical, it could be hard for enterprises to adopt new technologies at the speed that other companies may be able to. However, not doing so puts them at a severe disadvantage when it comes to being able to have the flexibility and agility in today's technological landscape.
That makes a lot of sense, and it starts to sound like the advantages that David talked about with cloud can really be leveraged for large-scale enterprise networking.
That is the future.
So David, let me shoot you a three-parter. What does convergence mean to you?
Mm-hmm.
Is this something new? And what's driving convergence?
I mean, there are two ways you could see that. One is sort of like the cloud is eating the world, right? It seems like everything is moving into cloud, network, storage, servers, all of these things, even some of the software that you're using. It feels like all of IT is kind of being subsumed under cloud. At the same time, we're looking at a world where everything is networked now, right? It just, we can't think of resources not being networked when we use them in IT anymore. That kind of gets to the second question, right? I mean, is this new? And no, it's not new. It's always been a goal of IT to efficiently share resources among users and to connect as many things to a network as possible, or as was needed anyway. So it's more about efficiency, right? And I think that's really what has been underlying cloud there. And then in terms of what's driving it, there are a couple of things I would point to. One is the use of SaaS software in everyday business applications, mobility and dispersal of the workforce. I mean, you think especially after COVID, the number of people who are working remote or hybrid. And then you think too about mobility and IoT, so we have a lot more things providing data to us in business now that we didn't used to think about.
So what's the future of network security?
Well, we're seeing the growth of SASE, which can manage security for users accessing applications from anywhere. It's already replacing firewalls and proxies with CASB and zero trust network access.
What about Internet of Things?
IoT security requires on-prem segmentation at the edge of the network. This is achieved by firewall services built directly into access point switches and SD-WAN gateways.
How does that relate to the cloud security?
Cloud security kind of, I guess that, you're trying to contrast it with on-prem security, right? Physical control of servers versus things being distributed on the network. I mean, a lot of the security controls are really baked in by the major cloud providers, right? Mm-hmm. And ultimately, it's up to the people who are designing the applications and the networks to, tweak that and make it fit the needs of the data that's being accessed, right? And I think you do have a lot of flexibility there, right? I mean, there are very secure services for data storage and access and so on. It's very customizable in the cloud. The main issue is the physical security of it, which is not your responsibility anymore.
Before we wrap this up, let's talk about what everybody's talking about, AI, right? Benny, how will AI affect networking?
I recently read where people will not be losing their jobs to AI. They'll be losing their jobs to people who know how to leverage AI.
Yeah.
AI and automation are advancing rapidly, shifting networking jobs from managing and configuring individual devices to being able to set policy and having that then implemented automatically and consistently.
What about monitoring networks? Does AI have a role there?
AI will provide insights and they will monitor the network for opportunities to improve. And that's really exciting because ultimately that's going to improve performance and reduce costs.
Does it ring true in the cloud, David?
Yeah, it absolutely does. I mean, I think, the same technologies that are being leveraged in, things like SD-WAN and so on, where you're seeing increasing use of AI to develop software to manage these networks, is going to happen, at scale in the cloud as well.
Cloud and networking is not that different. We think of it differently, but we shouldn't, right? We're starting to see the skills, the techniques, the technologies all converging. How does this all come together for you?
Yeah, I mean, what I think about in terms of the sort of converged future that we've been talking about is really, what does this enable, right? I mean, when we're talking about the cloud and networks, we're talking about infrastructure. And what I'm excited about is the really cool things that people can do building on this, right? You think about certain software architectures that weren't even possible until you had broad scale in the cloud. So what this is going to enable in terms of what people can build is really what gets me excited.
I'm super excited to see what you two are cooking up for the future generation of degree programs at WGU School of Technology. We'll definitely have you back in a future episode so that you can fill us in.
Look forward to it. Thanks, Huff.
Thanks for having us.
None of these great insights about convergence and the future of connectivity matters without people to implement, maintain, and secure the networks and the associated technologies that operationalize them. Ted is the founder of IQ Clarity, an innovative staffing company that solves business problems with exceptional people, and he has over 20 years of experience in the tech industry. How is the job market looking for cloud and network engineering?
Yeah, that's a great question, Dave. The market for cloud and network engineering has been strong for as long as I can remember. Obviously, here in the new year, actually CIO Magazine has rated cloud architect as the second most in-demand skill set for 2024. Salaries have continued to grow. Network engineer, I think the average salary is right around 100,000. For a cloud engineer, average salary is about 150,000. That just showcases the continued demand for those particular skills.
Are you seeing any trends that merge or converge these two previously distinct disciplines?
Yeah, we have actually noticed there's been some convergence between moving to a hybrid model where you've got physical on-prem infrastructure as well as pushing some services off to the cloud. That's a little bit in its infancy. What we're noticing more is specialization, which within each of those categories. So on network engineering, we've seen a huge spike in the demand for wireless. So wireless network engineers, engineers who understand the cutting edge 5G, even 6G networks. There's been a spike in demand for Internet of Things, so network engineers who understand how to make devices work, on a wireless network. Edge computing, software defined networks, those have become extremely popular. On the cloud side of things, we've seen a huge spike in using the cloud to support these AI and data initiatives. So anyone with cloud engineering, as well as some of the data services that go into these big cloud players, that's been very popular. On the other side, we've seen a little bit of a cost containment model where organizations' cloud spend has spiked in the last several years. So there's been a big push for cloud engineers who understand how to optimize their infrastructure to support a contained cost model. So they're not, when they get a spike in users, the spike in cost goes way up as well.
So it sounds like in the networking space, stay general, but keep up with new tech, and in the cloud space, specialize with one of the big three players. Does that sound about right?
Yes, I think just staying current, making sure that you understand wireless concepts, that is sort of the direction that everything's going. But yeah, that's going to set you apart as a candidate getting out there, somebody wanting to get into this field.
Thank you, Ted. And I look forward to picking your brain again in future episodes of The Connection.
Absolutely.
The convergence of cloud computing, network engineering, and security reflects a holistic approach to IT infrastructure. As organizations increasingly adopt cloud services, the integration of these domains becomes essential for ensuring the overall resilience, performance, and security of modern IT environments. It's not just the technology and its application that's changing. Education and training programs in these fields are also adapting to provide professionals with the interdisciplinary skills needed to navigate the converged landscape effectively. At Western Governors School of Technology, we aim to stay on the leading edge of these innovations and to fulfill our promise of creating opportunity through education. Thank you for joining. Thanks, Benny, David, and Ted. I'm Dave Huff, and I hope to see you all at another installment of The Connection.